How's everyone doing? I know I'm a little late. Thought I was going to be early, and then I got sucked into a chat on Discord. So, just a little late. But that's good. We have really good conversations on the Discord. So, if you haven't joined the Discord yet, there is a link. So, you should join the Discord in general. All right. So, today we're going to try things just a little bit differently. We're going to do one thing that we're doing differently today is something we won't do on the Tuesdays and Thursday streams ever again. It was me not thinking. But that is fine because we'll take this as a trial run for the real run, which will be Saturday. My Rust classes, I think people have really been liking. And what I'm going to do is we're going to do them live on Saturdays, and then I'll make the recorded video. Still going to make the recorded video, but the really nice thing is I'm going to be able to get your guys' questions and comments and concerns, and I'm going to be able to record the answers and those types of things in those videos. And maybe if the question is big enough, we make a whole nother video on that, and that's fine. But it's going to help us solidify the class and make sure all the real questions are answered. So I would actually really encourage you to join the live stream and of course watch the video because I put work into it. I'd appreciate it if I got that view. But I would really encourage you to watch the live stream so you can actually help make the content better for the people that come and watch it. You can also during the live stream recommend a whole bunch of different things like animations that might be helpful during that. So if you don't mind helping me, that's what we're going to do. So we're going to kind of do a test run of that today, and then I'm going to do it the same one again Saturday at 11 p.m. or 11 a.m. Eastern Standard Time. And basically we'll just do the class then, and then if it ends with enough time, we'll do some elevator after that. So today, what are we doing? We're going to do the dry run of the Rust class. And that's what we'll do first. And then after that, we're going to play with Go Generics. I haven't really used them yet. When they came out in 1.18, they were really bad performance. I read a lot of people that, tested them out and they were like 40% slower than the native code. That's a pretty big hit. But they've had improvements in 1.19 and 1.20. And so first, we're going to learn how to use them. And then we might even do our own tests just to see how much different they are than the native code. I think it will be fun. So that's what we're going to do. Hey, Russell, how are you? All right, so today's Rust that we're going to do is flow control. Now, I say flow control, we're actually going to be skipping one very specific portion of flow control. And there's a reason for it, and I'll get into that just a little bit. Basically, there's loops and those types of things that you can use. And the reason I wanted to wait, so like for loops, while loops, things like that. And I don't know. Maybe you guys could convince me to go ahead and add them. But my thinking is I know that sometimes people get confused with those and ownership. So like if you actually use something in a loop, it could get confusing. And so I thought that the right thing to do would be to put those things after our ownership lesson. I think that's lesson 8, where we kind of, I'm not going to say deep dive into ownership and lifetimes, but we, get pretty familiar with it. That's what I was thinking. Because again, the other thing is like when you're talking about loops, a lot of times you're talking about looping over something like a vector. And then you have the things inside of a vector, and are they mutable, and are they, and if they're mutable, what does a mutable thing mean? And so that's where like I really feel like those things are easier to do. I can show you a for loop, but does that really help you if you can't really leverage it? That's the thought. What do you guys think about that? I have a little bit more of a pragmatic way of saying that for the video, I think. But one second, let me. So, Russell, I go back and forth with dependency injection. I go back and forth. Uh, I love the concept of dependency injection. I hate inevitably where like it leads to. And what I mean by like I like the idea. I like the design pattern where your functions don't go out and get things. Your function is given everything that it needs. And then usually you also then say, well, how about we give it an interface? And then that way, we could have two of that type of interface, and that interface only exposes the things that it needs to care about. So you're reducing the scope of what it should care about. And if it's not in that interface that it's given, then guess what? It's not part of the scope of things that you should be concerned about. And if you need it, you need to be rethinking about whether that interface was a good interface. And if it is a good interface and is appropriate reducing the scope, then you've got to, think about whether that function should be doing it. That's like the dependency injection baseline. And then, but when everybody talks about dependency injection, they talk about these like, I did a lot of dependency injection in Java, and it literally got like crazy with like XML definitions of things that then would automatically inside of things inject stuff, and it got really weird. And then you got these other ones where it was like actually a singleton framework that did your dependency injection that you registered to. You created a simple demo and it works. It felt wrong though. I've been there. I've been there. Yeah, so I don't know because what you said sounds cool, but I feel like that's the trap. Every dependency injection framework has fallen into is we could make this a little bit better by going down this path, and then they full sail on that. They Leroy Jenkins right down into it, and at the end it's like, wow, you just added this entire massive thing. If I was to use a dependency injection framework again, it would have to be the lightweightest thing ever. Like that's, and actually I feel like macros from Rust could actually do it. I feel like maybe you're onto a way to do a lightweight dependency injection. Yeah, I would just that's like, again, I love the concept. I love the design pattern. If that's what we're talking about, I'm all in. Some of the frameworks I've gotten burned by. Oh, they're built into the framework? Cool. All right. So let's do this. I'm just gonna get into our code here. We're going to let's see. We have we'll this is just kind of where I do each lesson. I just do it in the same folder. Now I do push the code into a branch. So there's a branch for each lesson. I know that there's not a whole lot here, but that's how I've been doing it. And so yeah. Anyways, Russell, what do you think about that? Should I cover loops like really really generically, and then when we do, see, the thing is, I don't want to combine it with the. I didn't want to combine it with the memory, the memory management, or not memory, but the lifetimes and the ownership, because that felt too heavy. That felt like it was doing too much. So I actually have it the next lesson after that, kind of as like, okay, now, but it does feel weird to not talk about loops in flow control. All right, let's go ahead and open this. All right, there we go. All right. And that was the other thing, is I'm trying to stick to about 10 minutes. And so I feel like we have a pretty decent amount of stuff to get over in the next 10 minutes. So let me go ahead and do this. I feel like if I can do it live in about 20 minutes, then I can do it in about 10 minutes in a recorded format. I don't like cut out a bunch of mistakes and things like that, but I do cut out stuff for time savings. Sometimes I cut out horrible mistakes, sure. Uh, but mostly it's to just keep it flowing. That's the idea. Okay, so the first thing that we're going to do is we're going to learn some flow control. But to actually know what's happening, I think it's best to learn to test our flow control. So what I'm going to do is we're going to do our flow control in a new function. I like this because I want to keep bringing us back to, basically I want to keep bringing us back to things that we've done. We've done functions now. Let's keep doing them. So we're going to make a function. It's fn, and we're just going to call this, let's call this, get input. All right. So I have if, else if, else. Are you going to do match and let else guards? Yes. So that's actually pretty much what I have here. We're really going to quickly, the plan is to read in from a standard in. This doesn't go in depth into error handling. That's actually the next lesson. But reading in from standard in allows you to get random input, but it also allows us to do checks on it, like, hey, did you input a space or a return key or things like that, which I thought was a nice thing, and you get to interact with your application as well. So, anyways, so basically, it reads some stuff in, and then it tries. We do some stuff like trying to parse it, and you can do some checking and stuff on that. And so we do match, we do if let, we do uh, we do if let. 1 second. Let me. I'm looking here. So we have match. We have if let. We have if. Um, yeah. That was the idea. Was for loops is to actually go into uh, iteration and memory and type safety, covering actually like the details, not like, hey, I made a loop that goes from 1 to 20. I could probably add that in here pretty easily. Um, yeah. So that's what I was doing. That was what I was doing. One, it's hard to get into 10 minutes. And the second thing is, I feel like really you need to have a grasp on Rust before you really dive into those, or else it can get really confusing really quickly. Like, I can teach you the happy path, but I really hate just teaching you the happy path when you're going to try to do something with like a real like a smart pointer, or owned or a lifetime value, and you're not going to understand it, and it's going to be either painful and a bad experience, or yeah. That's why I was just making that their own episode. We can then focus on it, experiment with it, and understand it. So, anyways, yeah, let's keep going. All right, we're gonna get input in here, and this is going to this will just return a string. So again, that is the dash arrow, and we'll do a string. A string is a smart pointer. We'll get into more of that. I'm just helping to reiterate the different things, and then we'll give ourselves some scope for our function. All right. So for this, we're actually, again, going to use some packages in the video. I'm not going to actually go into the cargo file, but we're going to have to use some stuff here, and so we'll use std IO, and then I think here we need self buff read and write. Okay, and then we're also we're going to use std str from string. This will be fun. All right. Now, let's I actually just thought of a thing. I was going to have us read the standard input from this. I need to rethink about how I'm going to organize this code, because what I was going to do is start by testing. Let's make sure we add these things to test. This standard input makes testing a little bit more difficult. So maybe we shy away from this. Or we think of a good way to test around it, because we could do an interface, but we don't know that type of information yet. So I feel like the ways that I would get around testing this, we don't know yet. So maybe this is a bad one to bring in right now. But we do want to do some tests here. So we're just going to do our config here, CFG, and that is going to be test. All right. Mod tests. And to keep it simple for right now, we're just going to use superstar. That keeps the test easy. We can get into whether you should use superstar or not. There's two schools of thought here. I'm not sure of which one I'm of the strictest opinion of. So I think that there's valid arguments to both schools, I guess. All right, so we're ready to test. We got their test set up. Visual Studio knows that our tests are there. Let's start working on this. All right, so we want to get some input from the command line. I'm actually going to copy in and paste in some code, because it's not really part of the lesson. It's just something we need to do. And this is dealing with the standard input library. We're going to print a line asking for input. Please pick a number. We're going to try to get a number from the user. Now, because this is not print line, the print macro doesn't actually send a new line, because we want their number to be typed on the same line. Now, that being said, though, a lot of terminals don't actually flush until they get a new line character. So if you want that flush, we're going to have to actually flush it. this brings up a cool little thing here. This right here allows things to know that we're purposefully not looking at the results. This flush returns a result object that we could do something with, and we're saying we don't really care. We're go ahead and try flushing. If you fail to flush, we won't know it. So maybe that's not the best thing to do here, but we're signifying that we know. You could even give this a variable name like I don't care. And this is still fine because this is saying, I know that it's returning something and I'm purposefully not dealing with it. There we go. But we're just going to leave it as this, as an underscore, because we're not going to do anything with it. Now let this mutable user input. Now we've talked about mutable, so we're making this mutable. That means that this string can change after allocation, and we're going to learn more about what makes things mutable and why this is important. But we're creating a new string. We are getting a new standard in, and then we are basically locking that and getting a read line. So we're locking the standard in, and we're reading a line, passing our user input. So this is going to get input from the user. This is pretty cool, and yeah. So if you notice here, another thing, again, as we're going, you have to tell it that it's mutable. This function needs a mutable string. If you look at this, it's going to say that it needs a mutable self, so it needs a mutable SDN, which this lock is what's going to provide that. And well, the lock is locking it. Sorry, not providing it. That's here. But let's keep going. You need a buffer that is a mutable string. So as we see here, we have our mutable string, and that's what we're going to work with. The loops in there. Okay. Sorry, I was just I was just reading the last chat and making sure that I wasn't behind, but it was the same chat, so I'm not behind. Okay, so cool. This gets us our user input, and all we have to do here then is basically user input. There we go. Again, remember I didn't do a return. This is the last one, no semicolon. There we go. Visual Studio is going to tell us we're not using this. We're also not looking at this result. Now, we're going to get more into this in just a little bit, but what would be better here is to actually return this entire result, which has a useSize and an error. But we'll talk about that in a little bit. And we'll talk about how to actually deal with this. How would we deal with this? But let's go ahead for right now and just make that an underscore. Say we're not going to deal with it. If the terminal has a problem, that's outside of our hands at that point. Okay, cool. Let's actually use this, and let's give it a try. So we're going to say let input equal get input, and then we're going to print this out. We're going to print line, and we're going to put that input in here. Let's try running this. All right, we'll do run this main one. And it says, hello world, please pick a number. We'll give it a number of high. And it prints out high. And this works. Well, is this what we really wanted? Not really. I feel like we really need to have a way to control the flow and let the user know that what they gave us isn't what we wanted. So let's make a function to actually check if what they gave us was what we wanted. And we're going to do this a couple of different ways. So we'll do another function here. Validate input. And this is going to take a string. So we'll do really quickly, let's see. We will take a string and we'll call it input string. And this is going to be I guess this should be valid input. Should probably be named something like this. Is valid input. Okay. Or there's another way that we could do it but we'll get into that. So for us, valid input is really defined about whether it's a number or not, because that's what we asked. And that's what we really want to get to. So we might want to have another thing that actually tries to parse this into a number. So let's add that. Function parse input. And we'll do input string. I'm going a little off my script here because my script got into things that I just realized right now. We're kind of well beyond how we were going to be able to test, which didn't make any sense. So I'm kind of rewriting this as we go. One second. Isn't a string going to move ownership when you call it? Yes, actually, I did want to do that on purpose just so that they saw the error, because I know people are going to get into that. And so, yes, it is going to move ownership, and it's going to be awesome. And then we're going to learn that there's a copy that we can call or clone. And so I'm going to bring that up just really lightly. Should I not? I can just avoid it, but I thought that that was something that as people are making functions, they're going to end up on. And so I just wanted to cover it really quickly as a, oh, look, here's this problem. Is that a bad idea? I can change it. I'd maybe put a comment saying this will fail to compile for anyone that watches the video and pauses. Okay, so I was planning on. I have changed just a little bit from the exact flow, but my plan was to, as soon as it fails. But I see what you're saying. Like if they pause it before we actually get to the failure, because right now it shouldn't fail because I'm not actually using it. Maybe it will actually. Oh, it. I don't think it will actually fail at this point. Yeah, it won't fail because I don't actually use it, and it doesn't have. So I would have to use the first function, then the second function, and then it would fail. So like I could do this here. Is valid input and give it the string input, and this won't fail because I haven't actually transferred ownership twice. Oh wait, I need to terminate. And this won't, because again, I haven't used it twice. Now, once I do it the second time, parse input, now it's going to fail because I transferred ownership. And you see that Rust or Visual Studio Code is calling it out. I see what you're saying. I was thinking that it would be clear, but maybe it won't be because like now we'll be like, oh, there's a error here. Why is it erroring? Because this is the exact same right here, and why is it erroring now on this one? And then I was going to be like, well, let's just move it above, and oh, does that fix it? Oh, now it moved to the other function, so this function is okay running by itself. Um, I'll think about that. I get the point. I appreciate it. Good call. Good call. Yep. Yep. Okay. Thank you. These are good things to have. If you don't mind, I am going to really quickly make a note. All right. So let's get back to it. So a really easy way that we could tell if it's valid is just to parse the number. All right, here we don't want a bool. We actually want a integer. Now we could just do an I32 here. We're gonna say that's the number that we're looking for, and we could then parse it here. So we could say, we'll just say let result equal input dot parse I32. What does it not like about this? You expected a semicolon. Why would you expect that? Input is a string. We should just be able to call parse on it, right? This is I put these on here. My bad. Or maybe there we go. I was like that should be right. We should okay. Sorry. Whew. All right. So what we notice here is that we don't actually get an I32 back. Yeah, turbofish before parentheses. Yeah. No, I was blanking on it. I was like looking at it. I was like, I don't know why. But yeah, got it. So you'll notice here that we can't actually just return this. We don't actually have an I32 back. We have a result, and we have to actually control the flow here. Now, what you're going to see is that returning I32 here on this parse is probably not the best idea, but let's deal with it and learn why it's not the best idea. If we want to return a result, there's several ways to what I'm going to call unwrap this thing here. The very first, and I highly recommend you don't use it. Oh, and actually, this isn't an optional. Never mind. The best ways to do this is through either if else or or if lets and match statements. I personally love match statements and use them quite a bit and allow you to do quite a bit of stuff with them. So let's try that one first. We're just going to match. And if you remember, we're going to match the result. And we're going to match that on, okay. And this is going to be a number, int. I don't like calling things int because that's usually a keyword. We'll just say I. So, Visual Studio Code already sees that it's an I32. It knows how it's unwrapping it. Great thing here with a match keyword is that you're missing a match arm. It's going to catch these things for you. So you have to explicitly handle them. Now, you can do a catch-all with a match. So let's say you don't want to catch everything. You can still do a catch-all. The underscore is the catch-all of things that you don't want to do. So you could do an underscore and say, anything that isn't okay, we just want to return 0. Now, this is kind of the problem that I was alluding to. We don't want to return 0. 0 could be a valid number that they input. And then if we're parsing invalid inputs as 0, this would then be a problem, right? So we don't want to do that. Now, the other way that we can do this here is, we parsed okay, but really, we don't want to be that generic that everything, and this is getting angry still. See, needs error. So let's just give it an error. Now, this is a catch-all errors. You can actually match on individual errors, but we're not going to do that. If you watched my previous lessons, you'll notice that we're actually returning the result of this. If we tried to return a string, this wouldn't be valid anymore because this needs to be returning an I32, and your static typing is going to say it can't. So while parsing the match arm starting here, it's not going to work. So anyways, we got to return a 0. But like I said, this isn't really what we want to be. So in flow control, a lot of times, it's better to pass these things on to the application that wants to deal with them. So instead of doing this, instead of all of this work, we could just pass the return value back here. So then we will return a result of I32 and parse int error. Now, what to do with that changes hands from us to the people calling. And really, the whole point of this function kind of goes away because we can literally just return the return of this. All right, but we're going to use this anyways because a lot of your functions, you want to do this. You could do other work here and still return the result. This is actually a really good thing is if you can give people the ability to make a decision on your feedback, do it. Embrace these types of things. Now, there's another type of return that isn't a result. So let's say you don't have an error, but you want to optionally be able to return something. There is an optional type. This says it might not be an error, but I don't necessarily have to return anything. I think a lot of times I resort to using result because I love well-defined errors. Especially that are meaningful when you can create a type of error that allows you to make to understand things about, and to basically branch off your flow. Those are really really great errors. All right, let's keep digging into this. All right, so we have our input here, parse input, and it parses an integer. Cool, and it returns. Now we parse our input, and we want to know if it worked. Now I showed you how to do match, but there's actually another way. If you only want to do something with it if it's okay, so if it wasn't error, there's a pretty easy way to do this. So let's get our return value here. Let's ret equals parse input. So this is going to parse it into this result that we have here. And here we can do something called if let. So what you can do is you can do if let okay. So you just do if let okay and assign and says equals ret. So basically, if this variable here equals okay, and I'm going to key you into something. I've told you that macros are really powerful, or I've told you that enums are really powerful in Rust. This result is actually an enum, and that's just how powerful these enums are. You could actually make your own container like this. Super powerful. Hint of just some of the stuff that's coming up in the future. All right, so this unwraps it and gives you the scope inside of here. So actually, let's use it in here. Print line. Your number was. All right. I. Oh, actually, that's a pretty good time to show you that you can't reuse input. Let me think about that. All right. So really, this should only ever print if we input a number. Let's test it out. Input your number, 41, 41. But I did something wrong. Oh, I didn't save it. There we go. Didn't save it. Those are the things I cut out of the videos. Okay. I was like, why is it not working? So if we type Merrick, it doesn't print. But if we run this and we type 21, it also doesn't print. So it never was okay. Well, we need to figure out what's going wrong then. So in that case, we really do need to handle the error case here. I think this is a perfect time to say, let's switch over to a match. I really don't find if let to work very well. If you also want to handle other things, match is a whole lot cleaner. So let's really quickly switch over to match. Match. And then error. Can I just do the normal one here? I think I can. I think this will work. We'll find out. All right, so let's run this. Invalid digit was found in the string. Okay, so we're printing out an error. Kind of cryptic. I believe this is because the return character, the white space, I believe that we need to trim this. I don't remember having to trim this before. Did I do something wrong? I would have had to have trimmed it, right? It's not. I don't have trimming in my notes. Hmm. Oh. I do have this. One second. I don't think I have to trim the white space. So the only thing I have in my notes that I had separately is I had this print line right under here where I'm basically purging, which I think this is actually going to what you just said, Russell, is it due from reading from the same line as the question? I wouldn't expect this. But yeah, let's actually breakpoint. That's a fantastic. Let's actually see what it's getting. This is good. I'm actually going to purposely put this in there for sure because it's good to actually be able to see the stuff as it's going. All right, one second. One second. Where did I breakpoint? Okay, so we have our print line, our get input. So I'm gonna break right after. I'm actually not going to print this right afterwards. And I'm going to basically just break on there. I think that's a good place to do it. All right, let's debug that. Please pick a number, 21. All right, and so here we can see all of our input. And so this is really helpful. It doesn't seem right to me. What did I... Oh. I think I am screwing it up. One second. Let's walk through this. Let's see. I am getting the user input and then calling parse. Let's look here. I am not clearing the buffer here, but this vector looks wrong no matter what. So I did expect 3 because there's 21 and then there's the return. That I did expect. The return is a character itself. The new line is a character. But these are not the characters I expected. This is a U and a U and a 162. I don't know off the top of my head what 162 is. I'm looking it up. What is 162? 168. I don't know why I was saying 2. That's the copyright sign. All right, so what I think I have here in my notes that I don't have over here was this print line. Basically, I ask for please pick a number. I flush because I want to flush it out. I make a new string, I get the standard in, and I read the line, and then I do a new line after read. That is the only thing. Now, I actually want to step through this, see what these are. So let's stop this. That's garbage. Let's run this again. Please pick a number. We'll have to step over this. Let's see, step over, flush that. Okay, new string. It's now reading the line, so we're going to give it 21. It should come back. Our user input string should have wait, is it getting Why does it say that I got parent failed to evaluate, no location? This is interesting. Wait. There's an error. There's got to be an error in one of these. That's the only thing I can think of is that this is actually failing and returning a failure. We shouldn't be returning a string. We should be returning a result. So let's... Oh, it's an IO result. That's garbage. I hate mixing IO results with real results. It is wild, though. I did this previously. I did this previously before. I'm just looking over my notes in the Google Doc. The only thing that I also did differently here in my notes is I had I actually assigned the result to something. I didn't actually use it though, which was bad, and I was planning on changing it. But let's actually just try to use it here. Wait, I'm not still running, am I now? Oh my gosh. I'm wondering if there's a weird thing if you ignore the result, it just doesn't do anything. So basically this tells you how many characters were read. So we'll print this out. I'm actually going to print this line above. I don't know if it does anything. Probably can't hurt. Probably. Try that on get in. Wait. Oh, inline never. I think it's being I don't know why it would be optimized out though. I return it. If it's saying this user input is getting optimized out, That's garbage. It shouldn't. I mean, I'm calling new on it and returning its value. And it's a smart pointer. That would have to be a bug, right? I might just not be thinking about something here, but um it might be this getting inlined out is possibly what I'm thinking, is like this whole thing gets inlined out because it doesn't realize it's doing anything. It's kind of wild. All right, I'm gonna run this and see. All right, there were 3 characters read. That's what I expected. All right, I guess I needed to debug. I was kind of thinking that would fix it. All right, we're going to do 42 because we know that that is the answer to everything. We're going to go until standard lock. We're going to do 42. All right, at this point, user input has been optimized out. Also, debug doesn't do a ton of optimization. I've got to be doing something wrong here. Well, why does this have to be so difficult? One second. Let's see. Let's actually dig into this error. Wait. The read was okay. I was expecting an error. Just getting inlined into main. Okay. I'm gonna do it. You are probably right. You write more Rust than I do, I believe. So I am just going to take one for the team and force this not to be inlined. That is like this. All right, let's just run that. It's gonna work. All right, maybe I didn't inline properly. 1 second. I don't actually tell it never to inline very often. And by very often, I mean like I've actually never had this problem where usually if something was getting inlined on me, there was a problem with my code that I found. I think the first time I did this, I actually did it all in main, and so maybe that's what it's doing. So maybe that's why I'm having the inline problem. I just did it straight in main, but I wanted to make it a little bit nicer. Tell Rust not to inline function. Okay, that's what I did. Did I misspell it? No. No. Maybe I didn't save it. Let's step over it again. 42. User input, no location. Huh. Well then, we don't get an error. We are just losing our string. All right, bear with me. I'm just experimenting at this point. Let me do this. Instead of calling get input here, let's let's inline it ourselves. Oh, let's just inline this. Instead of that, we will do user input there, save that, and run that. 42. Okay, it was still not valid. Okay, I feel like I've done something to break this. All right, so our return was okay. It's 3. That's what I would expect. User input is 42. Wait. Why is it quote 42? This might be right. Wait. That looked fine. Now our parse input. Okay, this makes sense now. Now this makes sense right here because user input goes away because it was owned by parse int, which is fine. We don't use it. We use the return. But parsing, okay, we actually need to have a thing here. Okay, one second. This is still wild because like it used to in the same function, it was even here going crazy. So I'm not. One second. 42. We enter. Now it has 42. Okay, and this is what I would expect. A 4, a 2, and a new line. This is what I expect. We step over, we read. We still have 42, 4, 2, and a new line. We parse input. We're going to step into this. Now, input is going to get consumed, but it should parse the I32. So now what is our return? Our return is an error. Invalid digit. That's fantastic. Let me just look if there's a trim white space really quickly. I didn't have to trim white space. Maybe reading from the input isn't. Is it just dot trim? I think it might be. Actually, you know what? I'm just gonna try dot trim. Just do this. I didn't think that would doesn't like that. Yeah, this is gonna return us a string. Not exactly what I wanted. So I still don't understand what was happening with this being in a function because it wasn't operating properly um, in a function. But we can do this. Let new string. I want to get away from this though. I didn't have to do this. If this works, this is garbage. Absolute garbage. Just it's not garbage. It just I didn't want this to be like a demo because this is like putting in a bunch of things that I have to tell them, don't worry about. And that worked. Okay, so it is just trimming. My notes don't have that. Well, shoot. Shoot, 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 shoot. I don't know how any of my code worked. And it did. I still don't know why this isn't working. Honestly. I've never had a debug problem inlining anyways. I find debug usually doesn't inline a lot of the time. Unless if it's like just a straight static string. So I'm going to have to rethink this code. The way that I initially wrote it in my notes isn't how I wanted to do it anyways. Just because I wanted to make it more testable. So what I was going to do is then do some validation on the input, this string here. Basically, I had this here. We were going to write these functions. I'm just going to copy and paste these in. Where we have a might fail. I wanted to show just a couple like one last one. So then the idea was to show 3 different things. So this might fail, and this is returning a result. This might return something. Like I said, I alluded that there's optionals and how to leverage them. And this is also using if statements, which I liked. And then might panic. I also thought if you're building a command line, I might as well show you how to panic and where this is going to bring it down. And basically, this was all based off of that integer that we parsed in. Can I try it without the lock on STN? I can. I'm happy to try anything. All right. I think without the lock on STN, like anything could be messing with it though, in theory. I don't think that's best practice. Oh, actually, really what I need to do is take this back. One second. Maybe I deleted too much. No, that was good. I'm just going to comment. No, I'll just delete it. I was going to comment, but then I hit the wrong button. Let input equal what was the function's name? Get input. That's going to return us a string. We don't need this. Actually, was this in our function? Yeah. Perfect. All right, let's try this. This should, in theory, work. 42. It did work. I don't know. What did I change? This shouldn't work. It wasn't. I don't know how this is working now. It is. Well, that's good. Oh, wait, no. I left the lock in because I didn't change this. 1 second. I didn't change it. And it worked. It worked without the lock, too. It's just working now. What did I miss? Remove the inline? Oh, now you're playing with fire. Now you're playing with fire. Oh, boy. It's fine now. It's fine. No problem. Okay, so I can work with this. It's all we have to do with trim. This will actually give me a really good debugging point where I can point out how to debug the and see that it has the new line in it. I think that's actually really cool. And then we'll just do this trim, which is kind of dumb why you have to do this. It's not dumb. I understand why it has to. People at this class won't know quite yet why you need to do why trim is actually just an str reference, and toString then gives you a string with ownership and smart pointer. They won't know, but you know what? Those are some of the things where it's like it's okay if you don't understand. We'll move on. See the value before trim? Sure. It's right now. But this is what I'm saying. Originally, right here, before trim, it was gone already. Input was just an invalid reference at that point. I mean, the thing that boggles my mind is it was an invalid reference in this function. Like if you paused right here, the string was invalid at that point. Wait. I don't know what you're asking me to do. Oh, wait. Debug and see the value before trim, please. That's what I just did. Then do lock and no lock. Okay? So I'm going to just stop. We're going to... That was with lock. So now I'll do no lock. And we'll do the same. It's the same. It's what I would expect. 42 and a new line. Whatever I was doing in my old notes, trim wasn't required. And that's fine. I don't mind putting the trim on there. The thing was, this wasn't how it was working. We weren't getting a 42 here. We never got this input to be the number. And I don't know what changed because nothing changed. We abandoned this function because we couldn't get it to work with... If I had seen this, I would have thrown a new line on it, but this was just an invalid reference at that point. I'm on board with you. I don't know how it originally worked without trim. Get it? I get it. That's how it is in my notes. Now, I don't care so much about that, except this function wasn't working because we literally were breakpointing in here, and this was not a 42 at that point. I don't know if that makes sense, but this function wasn't working, but now it is. But now it is. Oh, actually, I want to. That's maybe a good point. You think maybe it was a terminal bug? Because it was in this function where we were pausing it, and this user input string was null. Like, I'm fine with the trim. The trim doesn't matter, and I get it. I even said I think it might be the trim, and then when we were looking at it, all this was null. Like all this not null. I guess it was null. It was the equivalent of null. Um, and that was the mind-boggling thing. If I had seen this, I'd be like, oh, it's because of the new line. And I think that's actually a really cool thing to point out to a class. So I'm fine and happy with this. I will do that. If I see it again, run the binary outside of VS Code in case their terminal is buggy. I like that idea because for some reason it was giving me a really strange thing. Like it was just saying like it had been inlined out. It was saying the input variable was inlined out. Like that's literally what it was saying. I don't know. I don't know. That was confusing. All right, this makes sense. The world has realigned. The moon was out of phase. You know. If Merrick is streaming, do this for at least 20 minutes just to screw with him. Sometimes I think that happens. Okay. The other thing was then to do this. Basically do some flow control on the input that was received. Basically make these functions, again, getting more practice making functions. And then the nice thing that we are going to do with these functions is we're going to add tests to them. You know, we want to test that this fails on a number greater than 10. Or less than 10. Sorry, I can actually read code. And so we're going to make that test. And then we're going to make a one on this that checks that it will return none if it's less than 10. You know, we only want big numbers. We won't test this one. I did want to show them how to panic, though. I think there's very few cases that panic's actually a good one. I personally like it when it's a microservice and you at the startup have failed to find something that you expected, like config. If you don't find the config that you need to run, you might as well panic and hard fail right then. Because then it sends out alerts on and everything that you have a service that panicked, and I feel like that feels good. Panic is great in admin of code. Panic, 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 panic. Um, yeah, I think there's some applicable uses of it. I think the majority of the times you should just return a result. Like, especially if you're building a library, you should always return a result. Never panic. Like, that's never the appropriate thing. You should let the application that's calling you decide if it should panic. Because maybe it should, but that's really on it. All right, the last thing that I had wanted to show is there's another way of flow control. So I showed you guys this if let. So basically you can do if let, okay, again, this pattern here. But one of the things that this can fail under is if then you want to do another one. And the problem that gets into here is, let's say you need to do another unwrap of something. And you start to see the problem. We now have another if let in here, you know, and you can start to see the nesting problem, and this can become a real problem. So what I wanted to show you was a what it's called let else. Basically, it says unwrap this or else do this one thing, which you can panic. If it's in a function, you can return. Since this is the main one, we can't actually return an error. But basically, it forces you to branch, and it's really powerful. It's one of the newer things, so let's give it a try. So we can do let okay. Wait. I don't know. Equals. Okay. Wait. I don't know why I have double things there. There we go. Why are you angry? Oh, wait. We're still in debug mode. There we go. Oh, parse limit. Yeah. That's fine. We'll just cut that out. There we go. Okay, so this allows you to, again, flow control, but it gives you a way to then use this integer is available outside the bounds here. So now we can print line with that integer value. And so I think this is pretty powerful, and for me, really, this is the way to go. I don't use if let a lot of the time anymore, unless if I really just want to return right then. Like, if there's nothing more to do, yeah. And this also follows the fail fast. If you fail fast, you should return. Now I'm panicking here because this is actually the main. We could just hit return. We could just do this. And this is going to exit out of the application. And if we wanted to update one of these, we could also do that. Panic will be the new null in 20 years. That's right. That's right. Then I'll have to change my channel to the Panic channel. That's Panic Labs. Trademarking that right now, just in case the future is sooner than we expected. All right, so those are the major flow controls that I wanted to cover. We're gonna go over testing some of these, and that was it for the most part. We're gonna very briefly cover I can't reuse this string once it's been moved. I do want to point that out just because I know that comes up when people are new and they don't understand why they can't pass it again because it's been consumed and it's a smart pointer and they don't understand it, and that's fine. And I'm just going to point out and then, also how to, get around that. And you're happy. Like, Just so that, obviously you don't want to be cloning things you don't need to clone. I get it. It's an introduction. They're very new at this point, so. Didn't I just cover that? I said instead of if let, you can do else let else. Isn't this? Didn't I just say how if let gets nesting out of control, and how I'm doing this from now on for the most part? Was that not clear? I talked about how you could do how we did like if let. Oh, well, to me, I thought that this was logic, but you mean like in here? Honestly, in Rust, I use match a lot more than I do ifs. Maybe I should go over and be like, yeah, you can do this, but then like, actually, this is a good point here because this is actually a prime opportunity. We can do like else if here, I is less than 20. We can, return okay 20. Just pegs it at 20. I'll rethink this. Maybe we don't return a number. Maybe we return the month they were born or something. Maybe we take this like maybe that would be a good one where it changes it from, a date, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Anything above 12 is invalid because that's not the calendar that we use. And then we go into how we could do that, and we could do an if let, if else I is equal to, 10. And we can go this way and then return a string. We'll take this to string and we'll return, what is October? And then we can talk about like how this is a little bit ugly, how it's a lot of extra typing, and if you want to do extra things in here and you have another if statement in here, we can start getting a lot of nesting. Or did you have something else in mind here? Obviously, this is also not the best way to do it because, you could do something with an enum. There's a lot of ways to do the birthday thing. That was just an idea off the top of my head. This isn't to write the best code, it's to prove a specific point. I don't like writing bad code or needing to explain that, but like, at the same time. This is to demonstrate a thing, not a and then we can really change all of this to a, match I um I mean, this gets stupid simple. Again, I probably wouldn't do it exactly this way, but I think for the example, it's actually pretty good. And then basically, we can then just do a catch-all. And this is a whole lot cleaner, straight to the point, easy to read. Yeah, or the if-else chains. Actually, that is one of the things, and I really think that if you see an if-else chain, it's probably pointing to a code smell. If the problem you're looking at, you're like, in this scenario, the only thing I can think of to get me out of this is an if-else chain, and I think this is true in Go as well. Like, I'm not saying just because we have a match, but if you're looking at a problem and your solution is an if-else chain, it's probably a code smell. It probably means that, you're probably right that right there you need an if-else chain, but that's probably indicative of a problem somewhere else in your code that's forcing you into that. I'm sure that you can find an esoteric example of where it's actually super useful. I'm sure everybody can, and it's probably in Ruby or JavaScript. But in general, that's my consensus. If you're writing an if-else statement, you've probably screwed up somewhere else. Yeah, and so anyways, I will do this where we actually refactor these. I want to show them the if statements anyhow because I think it's important to understand that it has all of the classics. But I think honestly, once you get used to this, this is so much like it's very powerful. It's very fast. Very good. Well, that bug, it's probably my bad. Took me longer than I meant for it to. I don't know why. I don't know why this caused me so much problem. So anyways, now I will be much faster. I'm gonna put all this in my notes. We'll do a real one Saturday. I'm glad I did this. Hopefully we'll keep it to a half an hour. I'll get some more feedback, and then my plan is to actually record that video either Saturday night or Sunday, some time, and drop it the next week. Maybe Monday. Maybe Monday's a good time to do it. Been wanting to bring back doing some Mighty Mini Mondays. People actually really like those. So I might do a few of those. So we'll see when I drop it, but that's the general plan. Yeah, I think I'll do Go on Thursday. What I'd like to do, if I'm devoting a whole time to it, is not only write the generics, but also do like a general test of like, this is generic code and this is, me actually writing it and see what the cost is. I've seen some other people that have done some things on it. I'd like to try to do some of those myself, just to test it. And I know that 120, which is what I have, um, I think. Yeah, 120. I know that 119 and 120 had made improvements, and I haven't really seen anybody since 119 and 120 do a performance comparison. And I'm not saying that I'm going to do the most in depth and whatnot. I figured while we're at it, while we're making some generics, we might as well also see if we can see a big noticeable impact, because it was like some of them were like 40% slower. Now that was like the worst case, and there was like best case was like 20% slower. Um, and so yeah, I'd like to see that. And then all of next week, I want to devote next Tuesdays and Thursday to Assembly Line and Legion. I'm actually getting really excited about Assembly Line. There's a Go bench that I was going to use. I don't know if it's popular. I honestly don't do a whole lot of Go benchmarking, so it will be fun for me to explore that a little bit. I actually did a little bit of it before this stream because I thought I'd have extra time, and I should have had extra time. Sorry, I feel like I was really unprepared, but I actually did prepare like 2 weeks ago. Now I haven't touched it for like 2 weeks, and sorry about that. That sent me for a little doozy there, but yeah, there's some benchmarking in in their test suite, but let me send you a link. This is what I was going over to do the benchmarking. So it's just like go test bench. So that's what I was going to do. Post in random my 10-minute mess about let me see. Oh, cool. Oh, you're building like a UI for Flutter? I thought it was a command line tool. I mean, having a UI would be cool. Does that mean our web would be in Flutter? I thought React was. Can't you do like React Native too? Or is React Native out? Is that out? And And we have to do Flutter. Build button spam 20 times. Yeah, next week I want to. I mean, I'm. Yeah, no, I think I was thinking just command line, but I don't think that there's a problem with the UI. I think a lot of power users are going to be okay with just a command line, but that doesn't mean a UI hurts. No, yeah, like Docker Desktop. No, I think you're right. I think that's a good idea. I wasn't thinking about it, and I wouldn't have ever done it because like you say React Native, and I start getting cold sweats. I think it's awesome. Well, I was gonna say we have a local, and then we have like a server UI, which I don't think the server UI needs to be able to run locally. Like I think it honestly would be different because like it can be, it's gonna store credentials and users and stuff like that and environment variables and it's a little bit different. Although I think maybe they would be similar as well. So like we could actually share like example, if it's React Native, like half of the components could probably be shared, uh, because yeah. But I guess if does Flutter do UI? I mean, I guess I am probably not the person that's going to work on the UI, so I probably really shouldn't have a say in how the UI is done ever. That's generally how I go. Um, but I've actually like the more I've argued with people, the more excited I am about assembly line, to be honest. I have talked to some of the people I know, and generally it's a very positive idea. Like generally they're all very frustrated with how less fun pipelines are in people's in different environments and versus locally, and they like the modularity idea and whatnot. So I'm kind of really excited about it. Yeah, and okay, so that I want to make another point. Like I was like trying to say for proof of concept, I would really like to get a proof of concept out there, um, and keep it like really narrowly scoped. That's why I was asking like when I was like pushing back on like being able to split and converge. It's not that I don't want to support those things. It's just like I don't know that like for core functionality that it has to be able to do that early on. I think you're right. I think it should, and I think it could be really useful in some niches, and maybe more wildly useful than I even think of if we had a tool that actually provided that out of the box. So I think we should. I just was trying to make some simplifying statements so that we could get out faster. But but we should know what version 1 like full blown should look like. And the reason I say that is because you can shoot yourself in the foot. If we never think about those things, you can program it in such a way that actually supporting those things is really hard. Not impossible, but hard. And so I think we should think about them. I think and this is one thing that I'm going to start doing on the GitHub is I'm going to they have iterations, and I was playing around with iterations, but what I'm going to do is the first iteration is going to be and you're supposed to put times, but I'm not going to worry about the times. What I'm going to do with the iteration is put the features that we want available for the proof of concept. And then I'm going to make another iteration that's another big chunk of time, like months, that is all about MVP, and then what I'm going to call milestone 1. Basically, MVP is like minimally viable product, but I want it to be like good, like usable, good, solid at that point, but maybe not have all the features. It's viable, but there's still features. And so we can kind of put them into the 3 buckets. And we can think of the 3 buckets as short term, medium term, and long term. I don't know. I'm trying to keep it simple, yet give us some way to sort these things out and keep track of them so that, it's easy. And then we can just focus on the things that are in the proof of concept, because I think once we get a proof of concept out, and if we get that out there, then people can play around with it and they'll give us feedback, and that might help us shape some of it, or get us some people to help. But yeah, I don't know. I'm the more I think about it, the more I'm excited about it. Truthfully, especially seeing like every single time somebody is like, "Oh yeah, and this other tool does a quarter of what you were saying." I'm like, "Yeah, so we were right. This is a good path to go down, but it executed poorly. Only half of the equation. Like I can go on and on. Yeah." All right. Well, I'm gonna let you get going because I know it's late for you. Thanks for sticking around. I really appreciate. I really appreciate you being here, so I don't have to stream to myself. I've enjoyed streaming. I do enjoy not today when I think the compiler decided it hated me, and it was just gonna inline a string. Not today, but most of the time I enjoy streaming. And it's so much more fun when there's actually people to interact with. So.